Hello, everyone. Thanks for tuning in. I'm Daniel, a solutions engineer on the TeamCity team at JetBrains. And in today's webinar, we'll be looking at how to build and protect your Unity games using TeamCity as the CI/CD solution and leveraging an integration with one of our partners, Appdome, which offers runtime protection for mobile applications, including those built with Unity. So we'll be showing a live demo of using TeamCity for configuring the Unity build pipeline and demonstrating the integration with Appdome for securing the application prior to deployment. So with that, I'd like to introduce Kurt from Appdome. Hi, Kurt.
Yeah. Hi, thanks, Daniel, and welcome everybody. It's great to have everybody join our webinar or catch the recording if you're watching after the fact. My name is Kurt Dusek. I am a product manager with Appdome, and as Daniel said today, we're going to be really going through how do we protect Unity games, or really any application, but specifically focusing on Unity games. How do we automate and build protections for those games directly into our pipeline? And so we're going to give kind of a quick overview of how this all works, and then we'll dive into our respective demos and show the whole thing end to end, and then we'll take your questions at the end. So a quick overview. There's two parts that we're going to be talking about today. So TeamCity and Appdome working together to build secure applications. And so the fundamental level of this is TeamCity. TeamCity is a great tool for orchestrating your builds, specifically if you're doing game development, and integrates with all sorts of different version control platforms and other types of tooling. And so TeamCity does a great job of managing the automation there. And within that automation, Appdome is a tool that works to secure your mobile applications as part of the build. So the important thing to know is that you can build protection directly into your application without having to write any additional code, without having to update plugins or refactor based on new versions of your platforms or operating systems that you're deploying to. And so that's one component of Appdome. And the other, or another component of Appdome, is how we actually monitor the threats that are being applied to your app in real time when those protections are built into play here. So this is kind of the view here of where it looks like in the pipeline. But the overview that we're going to go through in our demo is configuring security protections, how you define what protections you want to live in your application, making sure that Appdome is part of your build pipeline. Daniel's going to give a great demo of TeamCity, giving the overview of how that works, and then how we monitor what threats may be attacking our application. And because we have the automation in there, we have a really easy way to respond to those. So that's kind of the high level overview. I'm going to let Daniel tell us a little bit, really about how does TeamCity first and foremost provide that foundation and orchestrate all these things. Take it away, Daniel.
Awesome. Thanks, Kurt. Sounds good. So yeah, this is TeamCity. So for those that aren't familiar, TeamCity is JetBrains' flagship CI/CD tool, and it supports a variety of different types of projects. So we say it's agnostic, but we do have some specific integrations that really help with game development. So for example, we have integrations with Unity and Unreal Engine. So we have build runners that make it really easy to configure those types of builds. We also have integration with things like Git, obviously, and then also services like Perforce, which is very popular in the game development space. So TeamCity at a high level allows you to define a very complex build pipeline. So if I show you a sample project here, and we'll look at the build chain or the build pipeline, and what's shown here is a very typical game dev build pipeline with Unity. So you might be executing some tests. You might then be building for a few different platforms. In this case, building for Android and iOS, and then signing it and then deploying it to the app stores. So in the demo today, I will show the configuration of this project for a few minutes, and then we'll delve into how Appdome comes into this and how that forms part of this build pipeline. So before I do that, I want to kick off a build just to show how TeamCity responds when you make a change. So for that, I will skip over to Unity, and I've got my sample game here. And what I like to do is just change the color scheme slightly. So if we change it from like a purple to a blue color, we'll save that and commit that change over in my IDE. And we'll just add a commit message, so color change, and we'll commit and push. And because I've got a webhook set up with TeamCity for my GitHub repository and where my code is hosted, what will happen is within a few seconds, TeamCity will see that new commit and trigger a build. So if I go back to the project page, we can see that a build has already been started off. My tests are being re-executed. And this build pipeline forms a few different parts. So I've got some tests. I've got a few different builds where I build the Android and the iOS build. I then have a section for protect where Appdome comes into play. And this is where I secure the Android and the iOS build. And we'll look at that in a bit more detail shortly. And then finally, I sign the Android and iOS builds before deploying them to the respective app stores. And in regards to iOS, I'm deploying the game to Apple's test flight service. And for the Android game, I'm deploying it as an internal testing release on Google Play. So this is a very realistic build pipeline. So if I first show you the project settings, just to give you an understanding of how this project is configured. So when you add a project in TeamCity, the first thing you want to do is tell TeamCity where that code is hosted. And in this example, my code is hosted on GitHub. So I've added my Git repository and defined the URL here. If you previously authenticated with a provider like GitHub, you can click the icon and it will show you a list of all of the repositories you have access to. Going back to the project settings, there are a few other sections to be familiar with. So for example, we have integrations with issue trackers. We provide integrations with various cloud providers, so you can spin up builds on your own cloud agents. So if you're using AWS EC2 for your builds, you can very easily have TeamCity spin up those instances for you as and when you need to run builds. So under the project, I have a number of sub-projects, and this is a great way of grouping different parts of a build pipeline together, and not only just for grouping in the user interface, but we allow a very granular level of permissions in TeamCity. So if you want to restrict which members of your team are able to run the deployment jobs, you can move those into their own sub-project and define permissions on that sub-project that restricts access to only those that are able to run deployments. So I've got a few sub-projects, so test, build, protect, sign, and deploy. Under test, we'll look at the way that the Unity tests are being executed. So under here, I have a build configuration, which is another name for a job. And within this build configuration, if I go to the build steps that are being executed for this job, we can see that I have a Unity build step. And this is a dedicated build runner that we provide in TeamCity to make it very easy to configure a Unity build. So you can very easily choose the Unity options through the user interface here, rather than having to figure out all the different command line options to execute as a command line build step. So we have support for automatic passing of the test results. So once you've defined the Unity version, the tests you want to execute, and whether you want to run specific categories of tests or specific test names, when I go to the list of finished builds, we can see once I view a build here and go to the test tab, which I shouldn't get an error. Let me just try that again. So when we go to the test tab, we can see all of the test results automatically passed by TeamCity. So there's nothing extra you need to do to get the test results to show up in the user interface. We can see on the left-hand side in the navigation bar, the builds are running through. So the Android build is finished. The iOS build is currently running, which is great. So if we look at how these builds are configured, if we look at the iOS build in particular, so under the build steps for the iOS build, I'm actually leveraging Fastlane for this particular project. So I'm first of all downloading some certificates and prerequisites from secret storage. And then in the final build step here, I run a command line build step, which is calling Fastlane. So if we scroll down, we can see the fastlane command that I am executing. And in my project, in my repository, I have a fast file which stores the definition for all the different lanes that I can execute. And this is what's generating the IPA file. So over on the general settings screen, this is where you can define the artifact paths. So I've told TeamCity to capture the token chaser.ipa, that's the name of my game, and I'm storing that in this zip file. And then if I go back to the list of finished builds, on the right-hand side, we can see a list of artifacts associated with each of the builds. So I can hover over the icon and you can see all of the artifacts that are maintained by TeamCity. So that's how you build the game. I've then got a section here called Protect because this is where Appdome comes into play. So once I have my IPA or my Android version of the app, I then want to protect it. And the way that Appdome works is they provide a plugin for TeamCity that gives you a build runner very similar to the like a Unity runner or a command line runner. So if we look at the settings for securing the iOS build, if I go to the build steps screen, we can see that there is an Appdome build to secure. And this is how you can define your integration with Appdome. So with this, I can tell it the location of my IPA file, and I then tell it the output name, so what I want to capture as the output. And with the fusion set here, this is an identifier that Kurt will explain in a bit more detail as part of his demo. And I've told TeamCity I want to private sign this, so Appdome won't do anything in terms of signing the game. I will do that after Appdome has taken the unsecured IPA file, and it will upload that to Appdome service, and it will automatically add in all of the security packages and bundle that and pass that back as a updated IPA file that we then store as another build artifact over in TeamCity. So over in the general settings for the secure iOS, if I scroll down, we can see I've got some artifacts here. So I'm capturing the secured IPAs. This is the one that's got the Appdome binaries included. So this is the secured version. And then Appdome is also generating a certificate in a PDF format, which I can embed inside of the TeamCity user interface. So if I go back to the list of finished builds for this job, we can go to the previous build, number 48, and you can see under the artifacts tab my certificate and my secured iOS build. And the certificate is just a PDF file that shows that this build was secured by Appdome, and we provide a way in TeamCity to define these custom tabs. So if you're generating a HTML report or a PDF file that you wish to embed inside of the TeamCity user interface, you could do that very easily in TeamCity. So once we've had the Appdome version of the binary secured, we can then sign the game. So if I look at the sign iOS and look at the configuration for this and go to the build steps, I have a few different build steps here, but very similar to before, I'm using Fastlane to do the sign-in. So if we scroll down, I've got a Fastlane lane called resign IPA, and this takes the secured version of the IPA from Appdome and generates our final signed IPA. And this is what we get at the end of it. So the token chaser secured signed.ipa. And if I scroll back up and go to the general settings, we can see under the artifact paths, the signed IPA is being stored in TeamCity as a final version, which we can then deploy to the respective app store. And how the artifacts are passed between the different parts of the build pipeline is all defined through the dependency. So under dependencies, we've got snapshot dependencies and artifact dependencies. And snapshot dependencies allow you to define your entire build chain. So you're saying that the sign iOS depends on secure iOS. So you're linking the two jobs together. And then we have artifact dependencies that allow you to pass artifacts through the build pipeline. And this is how you can make sure that those artifacts are present on the machine where this job is executing. So that's how the binaries are signed. And then if we look at the deployment, which is the very final stage of the build pipeline. So under here, I'm deploying to Android and iOS. I then have a very final job which combines the two results of those together. And that's where my trigger is defined when I submit commits to my repository, and TeamCity will then figure out which dependencies in the build chain need to be re-executed. So TeamCity has the logic built in to automatically figure out which dependencies in the build chain need to be run based on the changes or the commits that have been made. So if we look at the deployment of the iOS app and go to the build steps, very similar to before, I'm making use of Fastlane to help with the deployment to test flight. So I have another lane defined in my fast file, and I'm just calling deploy to test flight, and this helps automatically deploy my final version of the game to test flight. And then very similarly, I have something set up for Android. So if I show you the Android version briefly. So under the build steps for this one, and look at deploy to Play Store. Again, Fastlane has support for deploying of games to the Google Play Store. So you can use Fastlane for deploying both the iOS version of the game and the Android version of the game. So it has helpers for both targets. So if we go back to the build and just see how this is progressing, we can see that the deployments are just running through at the moment. The iOS one is almost deployed. But what I'll do is I'll show you a previous version of the game that was already deployed. So if I switch to my phone, I have the Token Chaser game loaded onto my phone, and this is a previous build that has been secured by Appdome. And there are various security measures that you can enable on the Appdome side, which Kurt will show as part of his demo. And you can toggle on and off various security measures, like whether you want to prevent screen share, whether you want to detect certain secure environments, whether you're running the application in a simulator, and if so, whether you want to prevent that. So for this one, I've disabled screen sharing of the game. So if I open up the game, what we should do, if we start testing, you can see that capturing of the screen is not allowed, and eventually the game will be quit. So this is just one of the protection measures that you can easily embed inside of your game without having to do any extra work. You just add that Appdome build step, and then the IPA or the Android app is automatically uploaded to Appdome service and then retained by TeamCity after it's been secured. And then you can deploy that secured version to the app stores. So that's a kind of high-level overview of TeamCity. So, Kurt, I guess question for you. So, how does Appdome help with what I've just shown in my demo here?
Yeah, absolutely. Happy to get into that. And thanks for giving that overview of all of the different parts of how the automation works, right? So we saw all those different things. And really the thing to keep in mind is that, the traditional approaches to security, things like code scans, static scans, obfuscation, or app store policies, those are good at providing a very basic level of security, but they don't really address things like malware, or compromised devices, or running apps under emulation. If you're writing an application and you want it to be protected, you really have to focus on it being a resilient application. And so a resilient app is able to detect not just if somebody's trying to cheat within the game, but they need to detect, am I running on a real device or not? Is there malware running on this device or not? Has this app been tampered with? So you really have to be able to look at things within the application itself, within the runtime, within the environment, verifying that the device is actually a real device. If oftentimes, the cool thing about Unity is that you can use one code base to deploy an app to multiple platforms, but the usages of those different platforms is going to be different. And so the approach to security, whether you're writing a web app, whether you're writing a PlayStation game, or whether you're writing a mobile app or a mobile game, those are all going to be different. And so, especially if you're concerned about cheaters or frauds or pirates or people that are trying to manipulate your game or cheat or grief or give your users a negative experience, they're antagonizing or harassing your users, being aware to detect those types of events and shut them down is going to give a great experience, not only for your users, because they're not going to have cheaters running around in the game. It's also going to be a great opportunity for you to maximize, hey, every instance of our app is running on a real physical device. We can verify that it's actually the real person who downloaded it from an actual app store, rather than being side-loaded in, or rather than being passed around or run under emulation or run in a container or something like that. And so, to look at this, we have to really get the idea of what is Unity doing. How do they approach this? Unity, typically speaking, is they're not really focused on security. So I have a page here that kind of pulls up from their knowledge base, and this is what you would see if a user were to do a search, or even if you do a search of, hey, I found a game that I don't think is a legitimate game. Maybe it's been compromised. Maybe it's a clone of a legitimate game that's been tampered with to inject malware or to serve someone else's ads. And Unity, they just basically provide an overview that says, that's not really our problem. Report the app to the App Store, maybe contact the original developer if you feel like it. But generally speaking, Unity is not a security company. They build a great game engine, but security isn't their focus. And so if you're in a position where you're paying the runtime fee, or your games are your business, be proactive about security in an intentional way. App Store policies and game engine policies and TOS, terms of service, for those platforms and services aren't going to help ensure that your app is resilient. And so that's really where Appdome is going to come into play. So what Daniel showed in the overview is a great idea of is a great mechanism for how you orchestrate this. So let's dive into what these protections are, how they work, and how we configure them. So what you're seeing here, this is the Appdome platform. And so we deliver Appdome as a SaaS. So you'll log in once you have an account. You can create basically the portfolio of the different applications you have. So as we saw, Daniel was building this token chaser application. And so again, the cool thing about Unity is we can write an app once and deploy it to multiple platforms. So we have an Android build for Token Chaser and an iOS build for Token Chaser. And so these are just items within our portfolio. And so what we can do here is I'm working in the Apple build of Token Chaser. And so what I've done here is create what we call a fusion set. The fusion set is really your security configuration. That's going to be the options and settings that you enable to build protections into your app. So Appdome has over 150 protections for both iOS and Android, and we can deliver those in a consistent way. And so we're able to look at things at a high level. And so, we're talking a lot about Unity and gaming and things today, but Appdome works for all mobile games. So regardless of whether you're building something with Unity or Flutter or React Native or Kotlin or Swift or whatever tool you're using, Appdome is agnostic to all of that. And whatever your use case is on mobile, Appdome is agnostic to that. So even if you're not doing game development, or games are just a portion of what you do, Appdome is able to provide those protections. And so based on the type of application you're producing and the users of your application, enable the appropriate protections as necessary. So you can go through this and define, if we're concerned about jailbreak detection and we don't want people with jailbroken devices running our app, well, we can simply enable that. And we have several different methods of detecting whether the app is jailbroken. And then again, we're constantly updating this. A couple of months ago, there was a new version of iOS and a new iPhone. So because of that, we need to adapt how we manage jailbreaking, because again, there's a new suite of tools to jailbreak the new iOS devices and the new iOS operating system. So again, our security definitions are keeping pace with that. So this is something where you can define the policy, but you're not worried about updating your internal security SDK or refactoring based on a new line of devices that have come out and need to be secured in a different way than the old devices. So the idea here is that you can define how you want these protections to work, and then you can configure how you want to respond to them. So in a lot of instances, there'll be an error message that you can display. So we saw it on when Daniel gave his message when he was running the app under the iOS simulator, where it just says, hey, this app is designed or is intended not to be run under the simulator, and it will gracefully close. And so it's not going to crash the app. It's not going to throw an exception. It triggers a graceful exit of the application. So it doesn't clutter up your telemetry system, your Firebase, or whatever you're using to monitor your app performance. And so we can display this error message to our users and let them know, hey, you're violating a security policy, whether that's in the environment itself, this is a compromised device, or this is an emulated device, or in things that are also running potentially on the device. So if we're looking for things like cheat protection or preventing cheats, there's several different things we can do, right? So there's the idea of memory editing tools. So a common thing is, maybe you run the device under emulation, or you run it in a container that simulates the device, and then you have tools that are manipulating the data in memory. So giving you 1 million tokens, or giving you 1 million lives, or whatever it is, right? So being able to edit that in memory is a common vector. And so we can simply turn that on, and it simply disables it fundamentally. And so we have the ability to dive down into some of these and also specifically target things like Unity code obfuscation, secure app signature. So we have multiple different ways to defend against the most common types of attacks. So when we detect one of these types of attacks, there's a couple different things that we can do. So we have the ability to do in-app detection or in-app prevention. And so at a high level, if we don't want to do really anything, we just want to say, okay, if this happens, we just don't want users to do that. Well, we simply turn on the feature, we have in-app detection by default, and then we close that application. If you want to get, from a developer standpoint and be a little more integrated into the use case here, what we can do is enable what we call threat events. And what this does is it basically creates an event bus or an API within your code. So now you can say, oh, this event has happened. Someone's trying to run a memory editing tool. We now have an API hook or a function hook that we can then say, let's write a response to this. Maybe we want to flag the account. Maybe you want to lock the account or send an email to someone or open a ticket on your internal backend. So you can respond to this event in a custom way or in an intentional way. And that's going to create a different outcome than just say closing the app. Maybe you want to upsell them on something. Hey, we noticed you're a really clever user who knows how to use memory editing tools. Maybe we'll give you a discount on, some in-app purchase bundle or something like that, or a coupon code for something, right? So you can do a little bit more than just shut your apps down. You can let users know, like, hey, we know this is happening. So, hey, if you want to play the game, if you like this game so much, you're willing to bend the rules and maybe try and get a little bit more out of it, hey, try and do this instead. Come go to our website and use this special promotion. That's going to be a different use case than a user who's really trying to exploit your app for their own gain, right? If they want to just extract tokens and then sell them on eBay in bulk, then absolutely respond to that. Shut the app down, deny their account, do whatever you want to do. But the intent here is that you have flexibility and you have the ability to respond in different ways based on different threats. And so just like we talked about, we have different levels of protections here. We're looking at iOS protection. So if I wanted to toggle over to the Android build of the same game, well, my level of protections are going to be a little bit different, right? So I have similar protections, but the nuance behind them is a little bit different. So for example, under our security tab, rather than calling it jailbreak detection, we'll call it root detection because it's a different terminology, it's a different platform. And we want to make sure that we're delivering that equivalent protection across both platforms. It doesn't make sense to deliver on multiple platforms, but then the iOS build is a little less secure than the Android build. Again, if the stakes are high enough and you have sophisticated actors that are working against you, they'll figure that out and they'll exploit that to their own benefit. So this is why Appdome has the ability to define these different fusion sets based on the type of app you're doing, based on the audience that it's being released to, based on your security concerns, and again, that level of protection that you want to build into play here. At a fundamental level, so we have all these protections, and you can go through and look at the obfuscation, anti-piracy, anti-bot, anti-fraud, all these different things that we have enabled here to defend your app. At the fundamental base level, we have what we call OneShield. And that offers 3 specific defenses. Now, if you don't enable any of the higher order features, but you just run your application through Appdome, you're going to get OneShield. So OneShield gives you protection against anti-debugging, anti-tampering, and anti-emulation. So those are the 3 biggest threats against mobile apps. And so you'll see that these are options. I can't toggle these off and on. These are included by default. And so we have several different, kind of components that provide this level of protection. And so again, if we can provide this base defense, then everything we add on top of that is going to be enabled as well. We don't have to worry about, we enabled a feature that's not totally secure because there's kind of a complementary feature to that needs to be enabled. OneShield gives you that basic protection, that foundational protection for you to layer on things like detections for, Game Guardian, if somebody's running that process in your app, or somebody's trying to modify your memory or modify your clock speed or manipulate that. Again, these protections are going to live above that. So the first thing we want to do is define the protections, right? This is something we set up. Typically, we're not going to be in this like we are in our code where we're modifying it and updating it every single day. We'll set these configurations, and then as Daniel showed, because that build to secure job, that pipeline, or that job is in the pipeline, it's going to build those protections we talked about into every single release of our application. And it's also going to give us what we call certified secure. And this is a security document that tells us the nature of the security that has been built in our app. So we have this overview of, okay, this is the version of our app. This was the time it was built. Here's some identifiers for the file size, the hash of what we input. And then what protections we're specifically building into our application. And so we can see what protections we've enabled, and then we can deliver this document to whoever's concerned about it. So whether that's our security stakeholders, whether that's somebody's running a security audit, whether it's the chief security officer, this is going to help you answer that question of how secure are we? That's what Appdome's certified secure really specifically addresses. And because it's delivered every single time you have a protected app, it's always very clear and obvious to know where the security lies. We're not worrying about this file getting lost, or, there was a gap, it didn't run, we're waiting for somebody to produce it. This is part of the automation, and it's going to go a long way to help us ensure that we know how secure our app is. And as we change the security protections, again, this file is just going to be automatically regenerated along with our secured build. And then we'll start to see these individual items change as we add new protections. So that's the build side. But now let's talk about what happens when we actually run our app in production. So in addition to the protections that we build in, Appdome also builds in what we call threat scope. And threat scope is threat detection and response specifically for your mobile application. And this is going to give us a couple key and very important numbers that we can measure. So first, it's going to show us how good of a job Appdome is doing. We want to see Appdome doing the thing that we want it to do, right? So we can select the number of events and filter the type of protections that are taking place, and we can drill down and get an idea of the types of platforms, the physical devices by manufacturer, the versions of the operating system, and then specifically what types of attacks are being applied here. So if we look at, we have protections for remote desktop and SSL bypass. So if someone's trying to circumvent our certificate, our SSL certificate, and inject a malicious trusted certificate, well, we're detecting that event and we're blocking it. And so that's letting us know, hey, this is Appdome doing its job. Well, the other thing we want to look at is what threats are out there that we're detecting, but we're not necessarily responding to. And so we can do that as well, right? We can look at the types of devices that are leveraging these threats. And most importantly, the thing that we want the detail on is what threats are taking place. So if I look at mobile fraud detection, if I click into that, I can see that there are 6,132 events of people trying to force Android virtualization on my app. I can see this is happening, and we don't have a protection against it currently. Well, so we know this is taking place. And the cool thing is that because we have Appdome built directly into our build pipeline, and because we can define what the security posture is and what the security policy should be, I can go back over here and I can say, well, my prevent Android virtualization feature is off. I want to turn it on. I want to enable this feature. And so because that build to secure plugin is in our TeamCity pipeline, well, what's going to happen is the next commit push or release or next run of that pipeline, well, now prevent Android virtualization is going to be built into the app. We didn't spend any time looking into what this is or scoping it or creating a Jira ticket or adding it to our backlog or trying to story point it or understand who it's going to go to or how it's going to affect our current velocity. We can simply say, hey, look, if we're seeing this as a threat, well, let's respond to it by simply enabling the right protection and then running our build through. So the outcome of this is you're going to have protection against the latest threats in minutes rather than spending weeks or months trying to understand and engineer and then go back to the drawing board when there's a new tool release that, again, circumvents this in a tricky and underhanded way that then your developers have to go and not only detect that is happening, but then also refactor your code. And then you get constantly in this game of trying to play catch up with the community that's trying to compromise your app. So ThreatScope is a great tool for letting you know what risks are out there. And then Appdome protections let you respond to those risks immediately. And so this is something that's going to be included again every time you run that automation through, and it's going to give you visibility into what's taking place on your specific application. So that is it for our demo. I appreciate the time and us being able to go through the application through the pipeline and the automation basically overall. I realized I stopped my screen sharing. Let me kick that open one more time. But the last thing we want to leave you with is basically if you want more or less more details on Appdome or TeamCity, you can definitely sign up for a trial on both. Go to jetbrains.com/TeamCity. Go to our Appdome. You can just do a search for Appdome free trial. You can run through either one of those. Feel free to reach out to me or Daniel on LinkedIn or however you want to connect. If you have a few more questions about how to build these protections into your app, I'm happy to talk about these. I know Daniel is as well. And I think we can turn it over if anybody has any questions or anything they wanted to learn about either product.
Awesome, thanks, Kurt. Yeah, I appreciate the demo. I do like all the visualizations that Appdome has in the UI. Very cool. Yeah. I guess an initial question we have is what would it take to add equivalent protections into a game or an app without Appdome? Is there any kind of time savings you typically quote, or how would you answer that question?
Significant time savings. That's at the high level, right? The idea here is that there's so much change going on in the mobile ecosystem, right? There was a new iPhone that comes out every year, at least. There's a new version of Android that comes out quite often. If you're in the Android ecosystem, there's all sorts of individual devices, proprietary operating systems. The Samsung operating system is a little bit different than the Huawei operating system, for various reasons. And those differences create threat vectors, right? Or they open up the opportunity to be exploited. And, the common use case is looking for just the weakest link, right? And if somebody's determined to, exploit an application, especially if there's money in the application, if there's microtransactions in the application, or if there's something of value in the application that can be extracted and sold in another market, right? It's go on eBay and do a search for, characters from your favorite video game, right? Transferring accounts of supremely leveled up users is super common practice, right? And some of that is done via grinding, but some of it is done via exploit. And so that's, again, something that you have to look at that to understand, okay, if this is valuable enough, how much time are we going to spend fundamentally looking at how do we stop tampering, right? We talked about OneShield. That's the first level of protection that has to be prevented, right? We can do all the root detection and all the malware detection if we want, but if we don't have the ability to detect and prevent the app from being tampered with, well, then you're basically leaving the app vulnerable fundamentally, because someone can take the app, decompile it, modify the app with whatever they want, add their own marketing ad tech into it, add their own analysis tools, add their own malware to the app, and then repackage that up and redistribute it, whether that's via sideload or another app store in another country or territory that you may not be in. So that's the most common threat, is focusing on how do we stop people from tampering and repackaging our app. And that's hard. Code scanning is not going to get you there. You need really somebody who's looking at the fundamentals of how to prevent that, and they become an expert at it. And then how many people do you need to onboard to wage war against the entire community that's looking at these malicious acts that are looking to exploit your application? So it's fundamentally kind of a losing battle. And this is where, again, just like you don't write your own CI pipeline automation tool because it's a massive amount of work. Looking at, hey, how do we protect our applications in a resilient and effective way? That's something as well that you're better off working with a partner whose focus is providing security, building automation platforms, making it easy to deploy apps seamlessly, making it easy to test in real time. And then your organization, your team, is focusing on the most important thing, which is building a great app, making a game that people love to play, taking advantage of the latest and greatest features and the newest hardware. That's where your focus should be. And then, working with partners who maximize what they do to help you deliver those amazing games and those amazing apps.
Cool. Yeah, makes sense. Yeah. And as part of a demo, it kind of demonstrates how great it is and how customizable the security controls are per game or per platform. As a game developer, though, I guess one of my concerns might be how the security measures implemented by Appdome will affect the runtime performance of a Unity game on the end user's device. Is there any significant impact on load times or frame rates?
Yeah, so the short answer is no. And the reason why that no is mobile has to be a great experience, right? We're all in a position where if your app takes more than 2 or 3 seconds to load up, you may swipe out and go play another game, or you may swipe out and go do something else. So we know from our perspective, from our users, from our customers, they say, look, if you're not delivering not only a secure experience, but a seamless experience, an experience that doesn't degrade how the app runs today, then it's not going to be that useful for us, because the app may be more secure, but if users don't want to enjoy it, or users aren't enjoying it, they're not going to come back. So in a nutshell, Appdome isn't doing any rendering. We're not loading high 3D modeled graphics. We're doing environment checks, right? We're looking at specific signatures for specific things and specific traits of the operating system that may have been compromised, or the app that may have been compromised. And those are actually fairly performant checks to run, right? We don't have to do a lot of computation within the system to do that. So the outcome of that is the check is very simple. It's typically on app init or on app startup. And so that's something that's at the millisecond level where we do those detections and respond accordingly. And then we can also do, again, the small detections we're looking for, stray processes and stray runtimes. They're not computationally expensive. We don't add a bunch of code. We're not adding a bunch of resources to your application. So the file size isn't going to bloat. The runtime isn't going to bloat. And optimization is really a key component of what we're doing. Appdome's been doing this for about 7 years. And so not only are the security protections in place, the optimizations are in place. So this isn't a cutting edge product that does one thing great, but we're still working through the optimizations. Optimization is something we include in every single one of our build, because ultimately we want to make sure that we're delivering a transparent experience for the end user, so they don't even know Appdome is there, right? That's the goal, is your end users, they just get a great app. They don't know that they're being protected.
Yeah, awesome. Yeah, makes sense. And how do you see such things in real life? Do you have any anecdotal evidence from your customers about the types of security issues that Appdome protects them from? I mean, I guess this comes back to the dashboard that you showed as part of the demo. But do you have any anecdotal evidence that shows the security issues that prevented?
Absolutely.
Yeah.
Yeah, absolutely. So we had a customer of ours who came to us and said, we're a company, we have a game, and we release this game globally, basically. And so it's in all these different regional app stores, iOS, Android. And there's one country in particular where we see an anomaly in the data. We see the number of downloads is correct. It looks good. The traffic on the app looks good. The user signups look good, but we're not seeing any monetization out of this region in particular. Everything looks normal except the amount of revenue we're receiving from the game. What's going on here? So the story was we took the app, we ran it through ThreatScope, and we can identify and we could pin down and say, okay, in this territory, what's happening is someone is downloading the game, running it under a machine, decompiling the game on a desktop computer. So they've cracked open the game. They're looking at all the SDKs and code that's in the game. They're then turning that into their code. They're removing your monetization API, so your ad tech display API, and they're adding their own ad tech API. They're repackaging the game, and then they're selling it under the same app store under their own name, under their own corporate entity. So now you have two copies of the app in this one app store. You have the legitimate copy, and you have a clone that is 99% the same game, but the ads revenue SDK has been tampered with and replaced with a third party, with a malicious actors SDK. And you can even do that, tricky UTF-8 character encoding where it looks like, it's an L and a T and an A, but it's actually a UTF-8 character, right? So they think they're downloading the game that they were intending to play, but it's actually a compromised version. And so that was something where the company didn't know that this was even possible. They figured, oh, hey, the App Store is protecting our game. They're making sure, they're looking at fraudulent entities, or our game is unhackable because it's on iOS, or, Google is protecting us. And that's really just not the case. As we showed with Unity, it's the same policy with Apple and Android, Apple or Android Play Store. So they're not really concerned about, is the app secure? I mean, they'll take it down if enough people complain, but they're not in the business of diving into individual applications and doing, security forensic analysis to understand what happened with games in their store or any title in their store. So that's an instance where if this customer hadn't noticed or hadn't taken a proactive approach to security, then they would have potentially over time lost hundreds of thousands or millions of dollars in revenue that they still would have had to pay for, right? Because all the infrastructure of the game is still there. All of the user accounts and customer support mechanisms and, account tools and profiles, all that stuff was still there. The only thing they were losing is the money. So it's lose-lose in the sense of someone else is maximizing and leveraging your infrastructure and your code and your IP to then pay themselves with very little effort in terms of achieving that. So that's when we talk about anecdotal stories, that's always the one that I like to talk about because people don't even think about that. And for a lot of publishers and developers, that's the absolute worst case scenario, is that you're still paying over time for all of the infrastructure and all the tooling that goes into delivering a game, but someone else is literally taking that money out of your bank account or out of your revenue stream because the app in and of itself is unsecured.
Yeah, scary stuff.
Yeah.
Yeah. I guess one final question is, I'm curious how the protection from piracy works and what makes Appdome unique compared to other solutions.
Absolutely. So again, that anti-emulation detection, anti-tampering, anti-debug, we call in OneShield. That's going to circumvent so many different methods, right? The typical malicious actor, the first thing they do is they get your binary and they want to run it in a virtual machine, right? They want to use their desktop computer with all the tools to slow down the clock speed or modify the memory or sniff your network traffic and manipulate that in real time. That's their step one approach. And if we can stop that, that's going to shut down a lot of people. They're going to say, this is too hard for me. I'm going to go on to the next thing. And so the second part of that is anti-tampering. Maybe somebody's really determined and they will do this on a mobile device. They do have tools loaded on a mobile device to decompile, recompile, and modify your application. Being able to stop the ability to tamper with the application, that's where we can stop something from being sideloaded to saying, hey, those app store securities have been removed out. Now this is just a binary. You can just move between devices. That's the most common threat people are going to take. If we're talking about piracy, hey, I want my game to go through these channels for distribution, right? It has to go through the app store. Somebody has to sign up for an account. They have to provision and pay, pay the installation fee or pay the purchase fee. When somebody gets in and tampers those and removes those checks out, then now your game can be sideloaded. It can be run on an emulated device. It can be run on a desktop computer. So if we're concerned about piracy and making sure that each app is running on a person, a human being's mobile device, that's the goal for anti-piracy, right? If we want to make sure that there's no gaming how the app can run, there's no modifying how the runtime performs its checks and its security validation. So that's where we have to look at this fundamental level. And that's why OneShield, that's the thing you get even if you don't enable anything else. Because if you're not stopping tampering, then you're leaving the door open for all the other malicious attacks to take place.
Cool. Well, that wraps up the questions. So, Kurt, I'd like to thank you for taking part in our live stream today. If anyone that's watching has any further questions, please feel free to reach out to Kurt or myself on LinkedIn, and we'll be happy to help. And thanks again for watching, and take care.
Absolutely. Thanks, everyone. See y'all.
Thanks.